Hello dear students, welcome to our channel Bichaya Chinta Chemistry. Today I am going to explain about the molecular orbital energy diagrams for nitrogen molecule. In the case of nitrogen molecule, nitrogen electronic configuration is 1s2, 2s2, 2p3. To explain the MOED diagrams, we should take the two atoms atomic orbitals on both sides. In the middle, we have to place the molecular orbitals in this way. To explain in better way, we should take the 1s electrons in the bottom side of the paper, next 2s electrons and 2p electrons. The same way we have to represent in the bottom to upside of the paper. Here in 1s electrons 2 electrons, 2s electrons 2 electrons and 2p there are 3 electrons. The same way another atom also having the 7 electrons. So totally 14 electrons present in the nitrogen molecule. By the linear combination of atomic orbitals, two atoms combine to form the two molecular orbitals. They are bonding molecular orbital and another one is the anti-bonding molecular orbitals. In this way, we have to show total molecular orbitals in the middle. For the 1s, we have for the 1s, we have to fill the electrons sigma 1s and sigma star 1s. 4 electrons are filled here. And in the case of 2s molecular orbitals, sigma 2s and sigma star 2s, 4 electrons are filled here. And the remaining 6 electrons are filled in the molecular orbital of the 2p, pi 2py, pi 2pz, sigma 2px. Here in this case, we have to remember this below 14 electrons, we should take the 2p pi, pi 2p pi, pi 2pz in the bottom side and sigma 2px above the pi orbitals. After filling these 14 electrons in the increasing order of their energy levels, we have to write the electronic configuration like this. After electronic configuration, we should calculate its bond order. To calculate bond order, there is a formula, that is 1 by 2 electrons in bonding molecular orbitals minus electrons in anti-bonding molecular orbitals. Here in the nitrogen, we have 10 electrons in the bonding molecular orbital and 4 electrons in the anti-bonding molecular orbital. So finally we got 3 as the bond order for the nitrogen molecule. So here nitrogen molecule is having triple bond between two atoms of nitrogen. Due to the presence of all the pair electrons in the molecular orbital energy diagram, nitrogen showing the diamagnetic in nature. In the same way, we have to write molecular orbital energy diagram for oxygen molecule also. In this, oxygen electron configuration is 1s2, 2s2, 2p4. For the two oxygen atoms, we have to write two atomic orbitals, both sides of the molecular orbitals, and we fill the electron configuration, the increasing order of their energy level. First, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Here in the case of oxygen onwards, 16 electrons present in the oxygen molecule. We have to take the sigma 2px in the bottom and pi molecular orbitals above the sigma. So after complete filling of the electrons, here we are observing two single electrons as in the pi star 2py and pi star 2pz. We should write the electronic configuration in this way. We are showing the increasing order. After that, we should calculate the bond order for the oxygen molecule also. Here formula 1 by 2 electrons in the BMO minus electrons in the anti-bonding molecular orbitals In the case of oxygen, 1/2, 10 bonding molecular electrons, 6 anti-bonding molecular orbital electrons. So finally we get a bond order is 2. Here in the oxygen molecule, double bond is present between oxygen atoms. Because of two single electrons present in the oxygen molecular orbital energy diagram, oxygen showing the paramagnetism. Because of this paramagnetic nature only, oxygen is attracted towards the hemoglobin. This is most important property explained by the molecular orbital energy diagrams only. Thank you friends. Please like the video to reach maximum students. Share and subscribe the channel for more videos.